Hello everyone, welcome back to the channel. Day 2 of learning Kubernetes with me. And today we shall be looking at the Kubernetes components. According to the documentation, this is the next thing to learn. And yeah, I hope you're enjoying it and learning along with me. Learning never stops, and it's one of the most exciting things I love doing. Updating my knowledge so that I'm better in the competitive market, and I can of course always apply this to any project, any job, anything, okay, while freelancing. And yeah, let's get into Kubernetes components today. And for those of you who have been learning with me while building the flight booking engine, this is not a stop to it, but something else. So every evening, like at 9 p.m. EAT, I'll be continuing to build the flight booking engine. And today, I'll try to get back to it. But every morning, I want to try to learn Kubernetes, okay, as much as possible. So let us study Kubernetes components. This says an overview of the key components that make up a Kubernetes cluster. They say this page provides a high-level overview of the essential components that make up a Kubernetes cluster. And I wonder how you guys pronounce this. So they could pronounce it as Kubernetes or Kubernetes. I'll be interested to know how you actually call it. Okay. Yeah. So here there's a diagram. Okay. I see a title here. Let me maybe try to expand it so you can also see it clearly. Let me just make sure that it's all clear on this other side. Okay, it looks clear. So you see this word in white. It may not be clear on your end, but it says Kubernetes cluster. We have here something called a control plane. I'll magnify more. Okay, I magnified, but I think it reduced it instead. So I'll get back to what it was like. So you see a number of things. You see cloud provider API. I see node. I see API server, control manager, in brackets optional. I see control manager. I see etcd, in brackets persistent store. I see kubelet, kube-proxy, scheduler, control plane, node. And again, if you know Kubernetes and I'm pronouncing the things wrongly, do not hesitate to let me know. All right, let's see what this is all about. So it says components of a Kubernetes cluster. Okay, so I guess they're now going to explain these down here. Okay, so the core components. They say a Kubernetes cluster consists of a control plane and one or more worker nodes. Here's a brief overview of the main components. Okay, now they say control plane components. So there are two major things. We have a control plane and then a node. Okay, so the nodes may be one or more. Okay, but ideally, when I read this, I'm thinking about two major components. Okay, one is a control plane and another one is a node. Okay, and from just the name itself, control. Okay, this word control gives me an idea in my mind that it's going to be controlling the nodes. That's what I think. Okay. And in computing, in general computing, okay, this is me out anticipating what it's all about. A node is simply a machine. Okay. This could be like maybe a Linux machine, a cloud machine somewhere. Okay. So I'm thinking that the control plane is responsible for maybe handling the requests that happen on the node. Okay. But let's go on and learn. Let me stop speculating. So they say control plane components. They says manage the overall state of the cluster. Okay. So if we look here, this is the control plane. It is responsible for managing this whole cluster. Okay. Then this control plane has a number of components, and each of these components are responsible for managing the overall state of the cluster. The first component here is called the kube API server. Okay. They say the core component server that exposes the Kubernetes HTTP API. Okay, so lucky for me, who's a backend developer, and maybe some of you who are also backend developers, you learn from this that an API is simply an interface for communication. Okay, so I'll understand that this this kube API server allows me and you to interact with Kubernetes, okay? Because it says exposes the Kubernetes HTTP API. When you expose an API, it is for it is for others to use, okay? It's not for you to use, okay? So this API is not for Kubernetes to use, but for us to use, to interact with Kubernetes, okay? For you to interact with an internal system, an API is exposed by that system for you to interact with it. So again, I read, it says the core component server that exposes the Kubernetes HTTP API. So that is what the kube API server is for, providing an API that we, the developers or the DevOps developers, interact with, okay? Then I'll go to the etcd. It says consistent and highly available key value store for all API server data. Okay, now this API server that enables us to interact with Kubernetes, okay, which is called the kube API server, stores information in key value pairs. Okay, maybe the request URL with actually the real value of the request URL. That's how I think about it. Okay. And of course, let's say that maybe many of you know what key value pairs are, but maybe I'll just show you. Think of it as something like this, okay? If this was a basic store, if I was to illustrate a key value store, okay, I would have a key, okay, and of course, keys are unique, and then its value, okay. Every key having its value, like so. So I'd have maybe key, like for example, maybe if you had, for example, a channel as a key, I'd say maybe channel, and then the key would be this will be the value, okay, a string. So this is how you should think about it, okay, that keys are unique, okay, and a key is used to map or to store a value. So keys are unique and helps you to achieve faster access, okay. That's what key value stores are for: faster access and storage in almost constant time. So that's what I understand by this. So we have the kube API server, we have the API server, then the etc ID. Kube API server is for interaction, okay, with the Kubernetes API, and then etcd simply is a key value store. Simply storage. One word is for storage, okay, for the API server. Then we have the scheduler, the kube singular. I don't know how you pronounce this, whether scheduler or scheduler, but I just call it a kube scheduler, and says looks for pods not yet bound to a node and assigns each pod to a suitable node. Okay, so I'm here so I see they've introduced another term called a pod. So I guess along the way we're going to learn about what a pod is. So pods have to be assigned to nodes. Okay, that's what I understand. If you look at the diagram here, okay, I see node, 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 node. I don't see anything like a pod yet. But what I perceive is that each of these nodes, inside these nodes, there's a pod. Okay, so the scheduler is responsible for picking what is called a pod and giving it to a node. Okay, and not just any node; it has to be a suitable node. That's what I perceive from this. Then I'll go ahead to see what they say down here. They're calling this the kube control manager. It says it runs controllers to implement Kubernetes API behavior. If I hover over this, because I see it was like a link, says I think it's giving a definition of what a controller is, or what controllers are. It says a controller loop that watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state. Okay, so the goal of this is simply to watch the state of the cluster. Okay, if there's a desired state that I want, okay, the controller manager ensures that that state is managed. Okay, that the whole cluster is moved towards that desired state. Then this is the cloud control manager. Okay, it integrates with underlying cloud providers, and they're saying this one is actually optional. All right, interesting. So there is the API server, which exposes an API for us to interact with. We have the etcd, which is a key value store. We have the scheduler, which is responsible for assigning a pod to a node. We have the control manager, which is responsible for studying the current state of the machine in our configuration and making sure that our state reaches the desired state. Okay, how does it do this? It studies the whole stack, okay, and says, okay, this developer wants me to achieve A, B, C. Is the current cluster achieving A, B, C? If it doesn't achieve that, then the control manager makes sure that we move towards the ABC state, okay? And then we have the cloud control manager, which is responsible for connecting with cloud providers. I would assume things like AWS and GCP and so on and so forth, okay? All right, so I'll go on to the next thing. So this is the first thing, the control plane, which is responsible for managing the state of the cluster, okay? And to manage the overall state of the cluster, you need to communicate with it. You need communication, which is the API server, the kube API server. You need to store something, which is the etcd. You need to schedule things, okay, which is the kube scheduler, looking for pods and assigning them to suitable nodes. You need a control manager, which enables us to reach the desired state. And then if you want to integrate with the cloud, you use the cloud control manager. And all these make up the control plane. Next up, I see what they're calling the node components. Now they're saying run on every node, maintaining running pods and providing the Kubernetes runtime environment. Okay, so all these are items which run on a node. Okay, so the first item is called the kubelet. They're saying it ensures that pods are running, including their containers. Okay, so now understand that a node, first of all, before this pod is run, it must be assigned to before a pod runs, it must be assigned to a node by the kube scheduler. That's how I get it. And then these pods, when a pod is running, inside that pod, there's a container running. That's something else I get from this. Then in addition to that, we have what they call the kube-proxy, which is optional, okay? And this optional kube-proxy, they're saying it maintains network rules on nodes to implement services, okay? When I look at network rules, I'm thinking about things like IP tables and things like that, maybe firewalls, okay? But that's me speculating, okay? We shall learn more as we go ahead. So they're saying, what they're trying to define services here. They're saying a way to expose an application running on a set of pods as a network service. So a service is simply a way to expose an application running on a set of pods. And I think we look at one of the benefits of why we should use Kubernetes. That was in day one yesterday. And one of the advantages they were saying is that Kubernetes helps us to expose an API. Okay. I mean, not to expose an API, but to have services. Okay. So you have a group of pods. Okay. And these pods are being exposed as a network service. Maybe I can illustrate it here better so that you understand it, okay, as I do. And of course, if I'm wrong, please let me know. So I'm assuming the number of pods. We have a pod, okay, we have a pod, okay, we have a pod, okay. So maybe say pod 1, 2, 3, 4, okay. And all these 4 pods, okay, are being exposed as a service, okay. Maybe I can call it, maybe it's a payment service, okay, for the application you're building, okay, the payment service. That's how I understand it, okay. But under the hood, take note that each of these nodes probably have maybe different IPs, okay. They have probably different IPs. This is how I perceive it, different IP addresses. And when a request is made, okay, you don't need to worry about the IPs, okay? All you need to know is the consistent service name, okay? You simply interact with the service name so that in case maybe under the hood, this maybe say node 2 crashed, okay? And it was restarted by Kubernetes. Remember, we learned about self-healing, okay? And it was restarted by Kubernetes, okay? And we have maybe node 2 recreated, okay? Self-healing working, and we have node 2 recreated, but this time it's under the same IP. the person who's making the request doesn't have to suffer to know the new IP address. Everything will continue working for them because their interaction is through this consistent service name. Okay, you don't need to worry about the changing IPs here. Okay, and the load balancing is done automatically for you. Okay, so this is my general speculation, and I expect this to happen. Okay, through the hype I've seen on the internet about Kubernetes. Okay, but yes, let's continue. So they say the kube-proxy is responsible for maintaining network rules to implement services. Okay. Then they go on to say container runtime. Container runtime is responsible for running containers. Okay. They're saying read container runtimes to learn more. Okay. This is something we shall look at later. Okay. So we have two components. Okay. I mean three. We have the kubelet, we have the kube-proxy, we have the container runtime. Okay. And they're saying this item links to a third-party product that is not part of Kubernetes itself. More information. Okay. No need for that. They say your cluster may require additional software on each node. For example, you might also run systemd on a Linux node to supervise local computers. I mean local components, not computers. Okay. So I want to summarize this. Okay. I want to summarize this how I've understood it. Nani Roy, thank you for joining today's live stream. How are you doing? Where are you watching from, Nani Roy? So let me try to summarize this. Okay. I'm going to do this. I'm going to summarize the components. Okay. Let's say, come on, let me use a better color. Okay. So basically, there are two components. Okay. We have number one. Okay. I'll do this. Good to know that you're doing well, Nani Roy. I'm also good and pumped up with energy this morning. Yeah, I'm pumped up with energy this morning to learn, relearn, and unlearn and get better. How is India? By the way, just a fun fact. When I began these live streams, I don't know what was wrong with my mind. For some reason, I thought people who will be watching will be from where I live, from East Africa. So one day I was shocked to see, oh, someone saying I'm from India. I'm like, wow, it humbled me. Thank you for watching from India. I wonder what the time is in India right now. Okay, but yeah, I love that you guys are watching along with me. Okay, so let's keep building this. So let's. Nani Roy says, "I've learned fast API through your videos. Thanks to you. I really appreciate that's humbling." Okay, so let's just summarize what I've seen so far. Okay, sometimes after reading something, I like summarizing. Okay, Nani Roy, that humbles me. Okay, so let us start. Okay, what are the Kubernetes components? Okay, we got the first one. Okay, there are two major components. I'll split this in the middle. The first one is what is called the control plane. Again, we've been reading together. We have the control plane. So since we've been reading together, don't be afraid to correct me in the chat. The control plane, and then we have the node. Okay. So this is mainly what it's made of. Okay. The control plane is what manages the entire state. Okay. Of the Kubernetes. How does the control plane help us to manage state of the Kubernetes cluster? Okay. Again, what is a cluster? That's simply a collection of items working together. Okay. From the word cluster, cluster means collection or group. Okay. So the control plane, for the control plane, again, like I've told you, manages state. Okay. If I can add a description somewhere, maybe here, and I say manages, it's a manages state. Okay. Or instead of saying manages, just say manages the cluster. Okay. That's a more generic name. Manages the cluster. This is the importance of the control plane. But for the control plane to manage the cluster, it is made up of sub-components, okay? The first one is called the kube API server, okay? What does the kube API server do? It exposes an HTTP API to allow us make requests to Kubernetes, okay? To allow us make interactions, okay? If you read the explanation here, you see it says exposes the Kubernetes HTTP API, okay? It's being exposed for us, okay, to use. This is the first component, okay? Then there's another component called the etcd, okay? This etcd is responsible for storing state, okay? Store is for storage in simple terms. Let me not complicate it by saying state. It is for storage and it's a key value store, okay? So key value stores are very important, okay? Because they give us fast access when doing interactions, okay? It is easy and fast to access something in a key value store and retrieve it, okay? It's actually constant time, okay? It's almost constant time always. Why? Because the keys are unique, okay? After that, we have another component. Who remembers any other component, okay? That you can let me know of. We have the API server, we have the etcd, we have the scheduler, okay? If you remember the scheduler, they call it the kube scheduler. And this kube scheduler is responsible for assigning a node, okay? For assigning, pods to a node or to a suitable node. After that, the other component, okay, is the cloud control manager, okay? Cloud. I think these things are easy if you understand the meaning, okay, of them. It's easy to know what to remember them. So the cloud control manager, okay. Looks like there's no space, okay. So the cloud control manager is used to help us interact with cloud services, okay. So which other one have I forgotten? Okay, I had forgotten the control manager, okay. So you don't have to cram them, okay. If you forget, then you always look up, but at least you need to know the meaning, okay. We have the kube control manager. So what is the kube control manager for? It is responsible for ensuring that our cluster meets the desired state. So the question you should be asking yourself, what is the meaning of reaching the desired state? I'll explain this again, how I've understood it. Let us say, like, for example, in your configuration, your desired state is maybe 3 nodes, okay? You have 3 nodes running right now, okay? 3 nodes are running, but this is the desired, okay? This is the desired. This is your desired state. You have 3 nodes running at the moment, okay? And the kube control manager looks, using the API server, studies the whole cluster and determines that there are 3 nodes running. No, this the actual, not desired. Sorry. This is the actual state. Okay. The current thing is that you have 3 nodes running, and the kube control manager sees that you have 3 nodes running. Okay. But according to your configuration, you want 4 nodes to be running. Okay. So again, what are nodes? Nodes are simply machines. Okay. Think of a node as a machine. Okay. So my computer can be a node. Your computer can be a node. Okay. In a cluster. Then this is the desired, I'll call it desired state. Okay. This is the desired state. Sometimes I like writing like this. It helps me understand things better. And again, we are all learning together. So in case I'm wrong, let me know. Okay. So the cloud control manager will be responsible for making sure that our cluster moves from the 3 nodes to the 4 nodes. From what is happening from the actual state to the desired state. This is the responsibility of the cloud, the meaning of the kube control manager. And I know it may confuse you, kube control manager and cloud control manager. The kube control manager is internal. Okay, it helps us to ensure that we have our desired state within the cluster. Okay, the cloud control manager is actually optional and is used to connect to cloud providers like AWS, yeah, GCP, Azure, and others. Okay, so that's how I've summarized the control plane components. Okay, so let's go to the next ones. Okay, these ones here. Okay, then next one is called the node. Okay, so like I told you earlier, we have 2 major components: the control plane and then the node. So I have summarized what how I've understood the control plane. Let me know in the chat how I've done. Okay, and if you have something better, please let me know and correct me. Okay, so let's go to the node. Okay, for the node, here's how I've understood it. Okay, for the node, number 1, okay, there's what they call the kubelet. Okay, I don't know if this is better color. Maybe we'd use this. Okay, we have the kubelet. I don't know if this is the correct spelling. Doesn't matter. But what matters is that I have to know what it does. Okay, the kubelet, if I remember well, is what is responsible for running a pod. Okay, this one runs a pod. So the kubelet runs the pod. Then inside that pod which has, so this kubelet ensure that pods are running. Okay, that maybe so using this, how I understand it is that the kube control manager has to interact with this and say, okay, is the pod running? Is the pod alive? Is it in its desired state? Then inside the pod, okay, so they call the container runtime. Okay, container runtime. If I can write this very fast. Okay, I want to make sure I try to write the correct spelling. Container runtime. Now, remember, Kubernetes is a container orchestrator. Okay, so inside the pod, okay, you have your containers which are supposed to run. But how will the container run? The container runs because of the container runtime. So this is what executes the containers inside the pod. Okay, so this guy manages the pod. Okay, and this guy is responsible for actually running the containers. Okay, all right. There's a third one I forget, so I'll check the documentation. Like I said, don't cram, just understand them. Okay. Then we have this, okay, the kube-proxy, which is optional. Okay, but for its purpose, like I've already remembered, but just been looking at documentation, is responsible for maintaining or managing the network. Okay, the network rules. Kube-proxy. So that's how I understand it. Okay. I see nothing hard. I've seen people on the internet complaining about spending a lot of time managing understanding this. But I think if you simply wrote it down like this and tried to think it aloud, it becomes easier. Okay, then maybe after 1 week again, I'll come back to this. Okay, look at it. Yeah, it's all about understanding. Okay, and I'm sure if in an interview you told an interviewer that there's a tool called a kubelet which is responsible for creating nodes. There's a tool for creating nodes, but I don't remember its name. He'll remind you that it's kubelet, and he'll know that at least you know that there's something which creates a pod, and you know that there's something which is responsible for running your containers. Okay, which is the container runtime. So this is how I've summarized it and how I understand it. Let us go ahead and okay. So they say the item links, this item links to a third-party project or product that is not part of Kubernetes itself. Okay, I can leave this. They say your cluster may require additional software on each node. For example, you might also run systemd on a Linux node to supervise local components. Of course, we know what systemd let me not say of course, okay? But systemd is a tool that Linux users are familiar with, okay? We don't need to know about it, okay? But of course, when you need it, you do research, and your research will always lead you to this, okay? In case you need to supervise local components. Maybe we can do that later. Then here they're saying add-ons, okay? They're saying add-ons extend the functionality of Kubernetes. A few important ones include this DNS. They say DNS is for cluster-wide DNS resolution, which is interesting because, like, course, now DNS I think is something that we all used to. Okay, if you don't know what DNS is, DNS, the D is for domain, the N is for name, the S is for server. Okay, domain names, I think system, not server, but domain name system. Okay, which is responsible, the system in the world. Okay, not in the world, but generally a system. DNS is a system for mapping domain names. Okay, so what is DNS? Okay, a system for mapping a domain. Okay, you want to know map a domain domain name to an IP address. To an IP address. That is what DNS is all about. Okay. For example, you can map, for example, if you had a domain name, for example, like you have youtube.com. Okay. This is the domain. If you can write this properly. YouTube youtube.com, and it's mapped to its actual address. Maybe it's 1.2.14, okay, 0.5. You get the gist. So they're telling us that there's an add-on called the DNS, which helps us for cluster-wide DNS resolution, simply mapping domain names to their IPs, as simple as that. Now, they say the web UI says for cluster management via a web interface. Okay, I think this is good to have, and I'm curious to see what they show us. Okay, how it works. Okay, I'm curious to see how it works. Then they have the container resource monitoring, thing for collecting and storing container metrics. Yeah, it's good actually to have monitoring. Okay, any stack should have monitoring. They're saying cluster level logging. Yeah, so monitoring, logging are all good things, okay, to have, and I'm sure we shall have this. But the main things are these, okay, the control plane and the node components. Then these are just add-ons. Domain name resolution, something user interface for managing everything, and I'm sure, and I'm thinking if we have this user interface, then we shall be able to, using this web UI, we shall be able to monitor the resources and to see logs, okay, what is going on under the hood. I think that's it. Is there anything else? Let me go back here. They're saying flexibility in architecture. They're saying Kubernetes allows for flexibility in how these components are deployed and managed. The architecture can be adapted to various needs, from small development environments to large scale production needs. Yeah, this is good to know. You want something to be easily you should be able to tweak it, okay, and manage it according to your needs. They say for more detailed information about each component and various ways to configure your cluster architecture, see the cluster architecture page. Okay, so yeah, we've gone to the end. Saying, was this page helpful? Yes, I'll say yes. I've liked it. Okay, it's pretty clear. I see nothing complex. Okay, it is short. I like the diagrams. I like the brief explanations that they've provided. Yeah, so that is it for the, maybe to summarize the add-ons. The add-ons off the top of my head, I know that there's DNS. Okay, there's what they call it. It is a tool for monitoring. Okay, so like you said, I don't remember the name, but I know they use. Okay, so I know that if I need to monitor something in Kubernetes, I know that there's an add-on for monitoring. I know that there's an add-on for logging. Okay, so if I need to know this name, come to documentation, find out what's the name. It's called cluster level logging. That's for logging, container resource monitoring, and the web UI. Okay, so I know that now the web UI is for seeing what is going on. Okay, But in my mind, in fact, even if you're just a backend developer or a front-end developer, okay, at least if you've been doing front-end development or backend development for some good time, even mobile development, you should know that there are logs and you need to monitor your application. That is something very, very popular, okay? So I'm happy that also in the side of DevOps, there is monitoring and logging, okay? And there's a user interface to see what we need to see. Okay, so yeah, I've enjoyed this short stream, okay? And I implore you to keep studying, okay? After this, write some notes. Make sure you think for yourself, okay? Sometimes you may watch something, but you may not grasp it well. So go ahead and study it for yourself. Go and give it time to think. And see you tomorrow morning with another stream when learning Kubernetes. But like you always know, in the evenings, I'll continue building my project. Yesterday, you should have seen me in the stream. I fumbled. Not fumbled, but yeah, I got stuck. I guess I was tired and I kept on debugging and just ended it. So yeah, sometimes they're bad days, but today I've woken up with strong energy. So see you in the next stream. Bye for now and have a good day.